already discussed about the linear regression, and today we will discuss about the metrics of the linear regression. So today we will discuss about the metrics of the linear regression, and a part of the multiple linear regression also will be discussed today. On Friday, there will be a class and which will be based on the three things. One is the pandas, another is the PMySQL, and the database connectivity between the Python and the MySQL. These three things I will taught you on Friday. After that, we will go to the project work, right? So in this week, we will the in as far as from the PCS global site, as I came to know that we will have to give a outline of the data science. So in that respect, the up to multiple linear regression is okay for you, and there is no need to go forward for the machine learning. Yeah. So we will wrap up the machine learning today in up to multiple regression. And then on Friday, we will go to the pandas, MySQL, and the database connectivity between Python and the MySQL. So I think I had made it clear for the project work. And after that, we will move towards the project. Is it clear to you?
Yes, sir.
Okay, sir.
Sir, your mic is off.
Is it
Yes,
audible?
sir, you are not. Yes, sir, now audible.
Yes, sir, audible.
In the last class, we had discussed the all these things, the prediction. We had discussed the regression, how to develop our regression model, and the interception, the all these things, and training the set, testing the set. So evaluate all these things I had discussed in the last class. So today we will evaluating the model which we had built. We want to evaluate the model, and this evaluation of model is mainly done on the supervised machine learning. So how this evaluation of the model is done? The evaluation of this model is done through the three different metrics: the mean absolute error, mean squared error, and the root mean squared error. So for mean absolute, so these three metrics can evaluate the model whether my predicted value, the predicted model, that is y pred, or the predicted value is how much it is accurate to the y test, that is my actual value. So we will calculate these things, and these things are calculated by means of these metrics. So mean absolute error is basically we subtract the predicted value from the actual value, and obtain the errors, that is the sum of the absolute values of those errors, and get their mean. So subtracting the actual value and with the predicted value, and we will get the certain errors, and we will sum those errors with the mean value. So this is the the from the metrics of the mean absolute error. So this is MAE means mean absolute error is equal to 1 by n, means the number of the terms or number of the predicted values n, summation of I equal to 1 to n, mod value of actual minus predicted value. So we will take only the absolute value over here. Next is the mean squared error. It is similar to the ME matrix, that is a mean absolute error, but it squares the absolute values of the errors. Also with the mean absolute error or closer to zero, the better. The mean squared error value is the squared so as to make the large errors even larger. One thing to pay close attention to it is that it is usually a hard metric to interpret due to the size of its values of the fact that they aren't the same scale of data. So mean squared error value is basically, here we are subtracting the actual value with the predicted value, and we take the mod of that these values, and we will get a particular error, and the summation of those error divide by the mean, we will number of the errors, we will get the mean absolute error. So mean squared error is basically the square of this actual and the predicted values. So mean absolute error, so this is the mean absolute error is the modulus of the actual value minus the predicted value, summation of I equal to 1 to n. So we will get the first error E1 plus E2 plus E3, right? And then we divide with the number of the items n. So that will get, we will get MAE, that is the mean absolute error. Now in the mean squared error value is similar to the mean absolute error metric, right? So just a minute. So sorry. So the mean squared error, it is similar to the mean absolute error. That means here we just square of this term. That means it becomes more lesser. So it will be more smaller. So the error will be more minimized. If you square those things, the error will be more minimized. So my actual value minus the predicted value, their square, divide by the I equal to 1 to total number of data items, divide is equal to the mean squared error. So in mean squared error, the error should be no more less, because we are squaring these values. The error will be more smaller in the compared to the mean squared error. For root mean square is basically the square root. This is basically the square root of the actual minus predicted value. That is the square root of the square root of the mean squared error is the root mean square error. So root of this is the root mean squared error, right? So in order to get all these things, we have to use a library function from sklearn.metrics. Metrics is a library from we from and we have to import what kind of error we want to calculate, that we will import. If we want to calculate the mean absolute error or mean squared error, then we will import the mean absolute error, or we can import the mean squared error, and then we test the two things. One is the target value, another is the predicted value, and we will get ultimately the result, how much the mean absolute error is 3.92. Here mean squared error is 18.94, but the actual root mean square is 4.35, right? So the actual and all of our errors are low, and we are missing the actual value by 4.35, at most lower or higher, which is pretty small range considering the data we have. See, the 4.35 we are, so this is also this is also a minimized error, this is also a minimized error. So we see that from these two we can calculate that whether my model is very much accurate or not, right? So the error is 3.92, which is absolutely near, which is 4, approximately towards 4, and this is 4.35. So my model is nearer to the accurate, to the predict, to our actual value, right?
Hello, sir. Your voice is not audible.
Have you got it?
No, sir. For just a moment, I didn't heard your voice, sir.
So these are the actual values, these are the predicted values. Now I want to evaluating the model. How much error is present? So this is 81, this is 83.18, 188, 141, this is 30, this is 27.032088. So I want to see how much error is over here. So I want to evaluate the model. So in that respect, this is my YPRED and this is my Y test. So I want to compare the YPRED with Y test, right? So there are different evaluation techniques over here. So these techniques, the model is evaluated by three different techniques. One is the mean absolute error, mean squared error, and the root mean squared error. So mean absolute error is basically the actual value minus predicted value, mod of the actual value minus a predicted value, summation of I equal to n, that is the number of the items, divide by 1 by n. So divide by the total number of items, I will get the mean value. So this is my actual value, this is my predicted value, and I will take always the absolute value since there is a modulus is over here. So divide of the total number of the items, I will get the mean absolute error. So this is the formula of the mean absolute error, right? So next is the root mean square. So root means mean squared error, or the mean squared error is basically the square of this actual and predicted value. See, the square of the actual and predicted value, right? Another is the root mean square, which is basically the square root of this. This is root mean square. Now we see that in this we are for calculating for evaluating the model from a scalar and dot matrix. I have to matrix is basically a library from for which the different error calculations can be made. And from scalar dot matrix, I'm importing the two errors, absolute and the mean squared error. We can here also, but in the output, it is seen that root mean square is also there. So root mean square is nothing but the square root of the mean squared error. That is why the two absolute error and mean squared error has been import. So this is always import numpy as NP, then as the mean squared error and the root mean squared error and is defined in the matrix, and matrix is defined in numpy. So that is why I am importing the numpy as NP. Then I am calculating this y test and y pred. I am calculating the y test and the y pred. So I'm passing the values of y test and y pred both in mean absolute error and mean squared error, and making the square root of this mean squared error, I am getting root mean squared error. So you don't have to write this 2f and 2f. Without writing these, you can able to run. It is seen that in the mean absolute error, the error value is 3.92, which is nearer to the 4, and root mean square it is also to the 4. So these two values are more or less are identical. So I think then the 4% of error is over there. From here I can conclude that my model is accurate, right? Have you got it? What I said? I will have got it.
Yes, sir.
So now in a multiple linear regression, what is a multiple linear regression? That's we see that when the data set has two variables x and y, and we go to the simple linear regression. Uh, in multiple linear regression, the formula is basically a little different, and we see that in multiple linear regression, the formula is basically y equal to beta naught, beta 0 plus beta 1x 1 plus beta 2 x2 plus beta 3 x3 plus dot up to beta n xn. So this is the multiple linear regression equation, right? In simple linear regression is we will consider only y is equal to b0 plus b1 of x, right? So this is a simple linear regression, but this is multiple linear regression, right? Where we have one predictor variable, when we have one predictor variable and one coefficient, then we say that it is a simple linear regression. But in multiple linear regression, we have multiple predictor variables, right? So in so this is basically uh, this is also a linear. This is also linear. So this is so that maybe create a two linear line which may intercept over here, but here only one linear line which intercept with y-axis, right? So this is also linear, this is linear. Here many lines may intersect here, this way, this way, this way. So if this thing happens, then we called it as multiple linear regression. But in simple linear regression, we are considering only one regression line, right? So when the target variable, both of them, well, the target variable is continuous and we are finding the regression where the target variable is categorical, then we called it as a classification problem. Until this point, we have predicted a value with linear regression using one variable. If there is a different scenario that we can consider when we predict using many variables instead of one. And this is also much more common scenario in real life where many things can affect some result, right? So they give an example over here. So in multiple linear regression, we also use the pandas and numpy, and from there we will create this path. But I had shown it in a different way. Please don't do this in this manner. What I had shown it, only give the path in that way, and then you can define the data frame. You will get the data frame by writing df.head. I will import the whole data set into the Python environment. If I want to make it describe an a round value, then it gives these things. Now you don't have to go these things. It is a Pearson coefficient linear model. You don't have to go these things right now. Now I had told you that matplotlib and and Seaborn are the two library functions which are used in Python for the data visualization. Here also we use the Seaborn. You can also use in the Matplotlib for data visualization, and you by data can be visualized by showing the figure, and you can plot plt dot figure with the data. You will get the we will get, you can make a figure out how the data set are arranged. So in here we get that the data set are scattered. The set are scattered in this manner. So from where the data set the two lines goes, we the data set are intersected. The line passes through these lines, through those points of the data set. Right. So after that, we will define the correlation. We will get the heat map of the data set. Now these points, so these are the demarcated points, red points are basically termed as the outliers. That is, they are not needed. So the line through which the data points which are nearer to those lines by which the line passes, only those data sets we will consider. Otherwise, these are basically these data points are far away from the data line. So they are basically termed as outliers. Right. So these demarcated points are basically in the outliers. So this is the equation of the multiple regression. Y is equal to b0 beta 1 x1 b2 x2 b3 x3 bn xy n. This is basically the linear regression line analysis of multiple regression. Now again we are entering in the same manner as we did in the simple linear regression, that is the petrol consumption and the average income. That is, petrol consumption is our targeted value and the rest are our the predicted columns. From there we will split the data set into the training set and test set, that is for building the model and other for evaluating the model. Right. So after that we have to, in order to, before I told you in the last class, before you want to develop the model or you want to fit the model, you fit the data set into the particular model, then we must have to reshape or shape in the data set, otherwise it will show the error. So that is whether our dimensions are identical or not, that we will check with the help of the shape. After calibrating our data model or scaling the model, we are creating the linear regression using the regressor, and then we fit the data model into the data set. Right. So in order to do that, we have to build first the linear regression model. So we build the linear regression model using regressor, and after that we will fit the data set into the model, that is the regression model. Then that is why we are writing regressor.fit uh, using the train. What we are doing, that is for building the model, the data set which are necessary, that is the X train and Y train. We are just fitting the model into the data set. Now want to fitting the data set into the model. Now from where the interception takes place, that we also calculated in this manner. So the line of interception is 361.450. So this is the point of interception. We will get to the coefficient of the regressor. So from there we get the corresponding coefficient values. In the same way, what we had did in simple linear regression, the same code, that is we have to we have to build the model using train set and test set. After building the train and test set, we have to predict the model, and we use this in order we have to predict the model, and we predict with the X test. So the result, so this is y pred, and then we compare our predicted value with the actual value, right? So y pred is equal to regressor dot predict to X test and Y test, and then we compare the predicted value with the actual value. So PD dot data frame, we get the actual value. Test set is the actual value. Test set actually is our actual value, and the predicted value is our Y pred. So it is seen that our predicted values are very nearer to the actual values. For After that, we will evaluate the model using different metrics in the similar way as we did in the simple linear regression. So it is we measured our model, that how much error is then there. We will measure it by the different kinds of metrics we are using. That is how much the percentage of error is present with the how much accurate is our model, which is determined by means of the errors. So in mean absolute error, it is seen 53.47. Squared error is 4,803.26. And the value of the root mean square is 63.90, which means the model is right, gets prediction or for wrong adding by adding the or by adding or subtracting 63.90 from the actual value. It would be better to have this error closer to 0, but 63.90 is a big number. This indicates our model is not predicting very well, obviously. So here also the multiple linear regression, the error is calculated by means of the R square, which is 1 minus the actual minus predicted square divided by actual minus the actual mean. So this is the R square. R square gives the matrix values. If you want to calculate the matrix value in terms of percentage, so R square gives you the values, metric values ranging from 0 to 100%. So here we compare with actual and to the predicted value, that is the coding over here, and we get the value of R. Then we compare the scorecard with the predicted value and the actual value, and we see that the result is this, which is basically a 39% of our test data, which is not a good result. It means that it leaves 61% of the test data is unexplained, right? So so I think it is more fitted. That is 70%. So it will be more fitted multiple linear regression. Okay. So this is what the two machine learning algorithm that is simple linear regression and multiple linear regression. You got it? Have you got it?
Yes, sir. Sir, I have a
Okay.
question, sir.
Uh,
Hello, sir. Can I ask, sir?
yes.
Sir, if the error is so high, so what we can do as next step
Then if the
to
error
make
is
the
high,
model
then
better?
if the error is high, then our predicted, then our model is not so is not accurate. Then we have to check again with our data, right? So we will want, then we will calculate. We will take another train set, X train set and Y train set. Again, we will scale those particular X train and Y train and compared with the Y test. We will always try, if the error is minimized, then our model is accurate. If the error is very much high, then our model is not accurate. Then we will leave that particular training set and move to the next training set of X train and Y train, and again we will calculate it whether the model is accurate or not. So I think we will wrap up over today over here, and then on Friday we will discuss on PHP MySQL, we will discuss on the pandas, MySQL, and database connectivity with Python. Okay, fine.
Is that Friday same time class?
Same time.
Okay, sir.
Okay, fine.
Thank you. Good night, sir.